6, circular and periodic functions. Find values of trig functions based on the unit circle. Use the properties of periodic functions to evaluate trig functions. Let's take a look at the essential question. Can I evaluate trig functions based on the unit circle? Can I graph the functions y equal to sine of x and y equal to cosine of x? Let's start by looking at the vocabulary we're going to be doing in these next 3 days. The first vocabulary word is unit circle. Unit circle implies that the radius of the circle is 1. And when we put a triangle inside this unit circle, we are going to have a triangle where we have an adjacent side to angle theta and an opposite side and a hypotenuse. So the cosine, remember, is defined as the adjacent over the hypotenuse. And since the hypotenuse is 1, then it simplifies to the fact that x is actually the cosine of theta. So the x coordinate is cosine of theta. Now when we look at the relationship of sine, sine is the opposite, which is the y coordinate, over the hypotenuse, which is 1, and that tells us that the y coordinate is actually the sine of theta. So in a unit circle, there's this special relationship. Let's take a look at what would happen if you're on an axis. So for instance, you're right here on the unit circle. That unit circle coordinate is 1, 0. And remember that the cosine of 0, because that's where you're at 0 degrees, the cosine of 0 is the x-coordinate. So the x-coordinate is actually this value, and that tells me that the cosine of 0 is 1. The y-coordinate is 0, and the y-coordinate represents the sine of 0, and that is equal to 0. Over here at this location right here, the point is 0, 1. This is the x-coordinate, this is the y-coordinate. The cosine of 90, which that's the angle it is equal to the x-coordinate, which is 0, and sine of 90 is equal to the y-coordinate, which is 1. And here's the definition. The definition is any point on the unit circle, the location, the x-coordinate and the y-coordinate are such that the cosine of theta is x and the sine of theta is equal to y. Let's take a look at this point on the unit circle. To prove to you that it was a point on the unit circle, I used the Pythagorean theorem to prove to you that r is equal to 1. So this definitely is on the unit circle. So we want to find the cosine of theta. We don't need to know what that angle is. All we need to know is the x-coordinate. And so here's the answer. And the sine of theta, all you got to do is look for the y-coordinate on the unit circle, and that's 3/4. So you don't have to worry about doing opposite or adjacent over hypotenuse. You just are reading the x and the y. Okay, let's take a look at this other point. This point is located right here somewhere. This is the point, so let's go ahead and draw right here. And then standard position, this whole angle would go all the way around, or we could have a negative angle that went down. In any case, this is theta, or you could be talking about the theta inside here. So this is the point location, -15/4 and -1/4. And we can actually find the sine and cosine without having to draw the triangle at all. All you have to do is identify the x-coordinate, and all you have to do is identify the y-coordinate, and you have the value of the sine and the cosine for this angle. Let's take a look at a triangle that we're used to seeing, and that's a 30, 60, 90 triangle. And so this is in a unit circle. So I'm going to make our 30, 60, 90 into a unit triangle, which means I want to divide by 2. I want to divide all sides by 2, and that's because I want this radius or this hypotenuse to be 1. I want that 1 to be like right here. And so that means this will be 1/2, this height will be 1/2, and that means this length will be √3/2. Now, as soon as I know the x-coordinate, which is √3/2, and I know the y-coordinate, I know the cosine and the sine. So the cosine is the x-coordinate, and the y is the y-coordinate. The sine is the y-coordinate. Okay, now this angle right here is 150 degrees. and 150 degrees means that the reference angle is 30 degrees. So again, the x coordinate will be the long leg, which will be negative root 3 over 2, and the height will be the short leg, which is 1/2. And now that I know the x and y coordinate, I can identify the cosine of 150, which is negative root 3 over 2, and I can identify the sine of 150, which is 1/2. To get 210, we would go all the way down here. That would again be a reference angle of 30 degrees. My x-coordinate will be the same as the other point right before that, but my y-coordinate, since it's in this quadrant, it will be negative. And now we can identify the cosine of 210 degrees, and we can identify the sine of 210 degrees, and we didn't have to find the opposite and an adjacent, we just had to read the point. Okay, over here, this is going to be 330 degrees. Again, the reference angle is 30, and our x is going to be the long leg, and our y will be negative 1/2 because we're in the fourth quadrant, and again, we're able to find these values. Okay, let's take a look at multiples of 60 degrees. Now, again, I'm going to make it into a hypotenuse of 1 so that it identifies, it looks like it's going to fit into the unit circle. So this is going to be a 1. So this triangle will now fit right here. This will be root 3 over 2. This will be 1/2. So this is the short leg along the x-axis. This is the long leg along here. So the cosine of 60 will be 1/2. The sine of 60 would be root 3 over 2. Now when we do 120, again we have a 60-degree angle. We're going to have the point here, the x will be negative 1/2, and the y will be root 3 over 2. Just like at this location, it was 1/2 root 3 over 2. So now we can find these values. And when we want to do 270, that 240, which would go around here, again, the reference angle is the same. The point will be a negative 1/2 again, but this time the y is negative root 3 over 2. And that'll allow us to write down these answers. And to get to 300 degrees all the way around here, again, a 60-degree reference angle. This point will be 1/2 now that we're in the fourth quadrant, and negative root 3 over 2. So you can see we were using the same coordinates. We just had to be careful about the sign, or whether it was positive or negative. And then we're able to evaluate these. Okay, now let's move to a 45, 45, 90. Again, I want to make it into a unit circle. So I'm going to divide everything by root 2 so that I can get a 1 here. And you got to go one extra step and rationalize. So this point right here is root 2 over 2, comma, root 2 over 2. That is our x-coordinate, and that's our y-coordinate, and that's what the value of cosine of 45 will be, and the sine of 45 will be this as well. If I go 135 degrees, that means my reference angle is 45. This point will be negative root 2 over 2, root 2 over 2, and that'll allow me to find these values as well. So I hope you see this pattern that I'm giving you here, and you might already be able to guess what this answers will be because they're both going to be negative. And I hope you can guess what these answers will be. One will be positive and one will be negative because it's in the fourth quadrant, and then we can put those answers right here. So I'm just trying to show you that you can find these values like that. Okay, so you know, we did a lot, and in a way all you have to really know is three numbers: 1/2, root 2 over 2, and root 3 over 2. Okay, the 1/2 and the root 3 over 2 show up in this 30, 60, 90 business, and the root 2 over 2 shows up in the 45, 45, 90. So I want you to get to a point where you can actually just give me the coordinates here. So this angle is 30 degrees. This is the long leg, and that's going to be root 3 over 2, and the height will be the short leg, which is 1/2. Now on a 45, 45, 90, we're going to be using this ratio, and the x will be root 2 over 2 and root 2 over 2. Now on the 60, remember this is the short leg. Short leg is going to be the 1/2, and the long leg will be root 3 over 2. So again, just 3 numbers. If you just use 3 numbers. Now this right here will be the mirror image. Mirror image, which would mean that it will be 1/2 root 3 over 2. It's the mirror image across this. And then this will be the mirror image of this one, which is negative root 2 over 2, root 2 over 2. So I hope you've seen this pattern of how we can find these things by looking at mirror images. All right, and one last thing that I got to cover, and that's determining a period of a function. So a period is what it takes before it repeats itself. So if this is the start and this is the finish, you can see then it looks, this picture right here looks like it's going to repeat itself right at this point. Then we go back here. So this whole thing, this whole pattern repeats here and here and here. And so we call this portion the period, the part that it takes to do the whole function before it starts repeating. So the period is pi thirds. So that's how long it is before it starts repeating. Okay, let's take a look at this one. And again, here is the start, and it goes up, and then we see that same point here. So here's the start. It looks like it's going back to the start. So this is the period, right? I mean, this is the function, and then it looks like it starts repeating. So right here is the period. What the period is how long it takes the x's to start repeating. And so the period right here is pi. Okay, and again, just 3 numbers. If you're working with radians, remember are another way to look at angles. In the radians, remember this is represents 30 degrees. This represents 45 degrees. This represents 60 degrees. So I'd like you to remember those 3 numbers in radians as well as in degrees. Okay, so let's take a look at some answers. It looks like I gave you the answer instead of asking you to do it, so that's my bad, but I'll go ahead and use this. 7 pi 6, so we look for 7 pi 6, that's right down here. Here's 7 pi 6, and it's asking for the sign. So what we're looking for, we know this is a 30, 60, 90 triangle, and the sign is the y coordinate. So we know this point, the long leg is negative root 3 over 2, and the height is negative 1/2. And remember, if I'm asking for the sign, I'm asking for the y coordinate. At pi 6, right here is pi 6. Pi 6 is like 30 degrees. The long leg is root 3 over 2, and the short leg is 1/2. And when I ask for the cosine, I'm asking for the x coordinate. The sign of 5 pi 6 is located right here, 5 pi 6. The long leg is negative root 3 over 2, and here's the short leg, and that is 1/2. And I'm here asking for the sign, and the sign is a y coordinate, and that is 1/2. Okay, these don't have answers. Okay, good. All right, the sign of 3 pi 4ths. Okay, 3 pi 4ths, that's that 45, 45, 90. And in this quadrant, this will be negative root 2 over 2. Remember, there's only 3 numbers, and then root 2 over 2. So we know that's it. Now this is asking for the sign, and so the sign is the y coordinate. Okay, 5 pi 4ths is located right here. And again, the reference angle is pi 4ths, or 45 degrees. So this is going to be negative root 2 over 2 and negative root 2 over 2. Remember, just 3 numbers. The cosine will be equal to negative root 2 over 2. All right, 7 pi 4ths is located right here. And again, the reference angle is pi 4ths. We're going to be using this root 2 over 2. The x will be positive, the y will be negative, and I'm asking for the sign. The sign is asking for the y coordinate. So this is root 2 over 2. Okay, and this is the end of the first part of the screencast.